you will do a 2 case study, and also we will cover a new chapter. Okay, new chapter, chapter 5 on the design of chemical devices, functional products, and formulated products. Okay, that one is maybe just an introduction about all these three uh, uh, what we call it as uh, B2C chemical products. Okay, they have 3 classes. Okay, but for now, please see this problem. Okay, I hope that you can open your iCast software. Okay, please open. Okay, and then click Pro CAMD. Okay, can you click Pro CAMD? So this is the questions, and where is the Pro CAMD? Okay, this one. Okay, but before that, uh, before you, it's alright. So once you open, you're gonna see this interface. Okay, just click Pro CMD. Okay, anyone already installed, right? Okay, I hope everybody already installed. Okay, so please do the problem. I give you about 5 to 10 minutes. Can you generate this one? Find out the binary mixture that form an isotrope with ethanol at 1 atm, where other compound is an acyclic compound having 300, okay, between 300 to 400 Kelvin. Okay, so if you get here that you can set, what you have to do is you can write the title first. Okay, for example, this one is a isotrope formation, right? Okay, so just click. Okay, Mac is not possible. Okay, I think you can try with the, how, do you have any other laptops or computer? Yeah. What's that? Send me the message. I could not install it as the installer only from a closer window. Okay, so I will confirm with Dr. Rafiza and Dr. Azizul. Is it possible or not for Mac? So please do this problem first. This one is from molecular design. Okay, find all the binary mixture that form an azeotrope with ethanol at 1 atm, where the other compound is a acyclic compound having 300 to 400 Kelvin. So for the non-temperature dependent is only normal boiling point, and all you have to set. Please do first. Okay, later I will show you the answer. How many structure that you can generate, and how many we can reduce it. Okay, we can do the screening. Okay, Okay, for TB, okay, you have to set between 300 to 400 kelvins. Okay, that is the constraints. Okay. Uh, Actually, the main also the liquid miscibility with the ethanol lah. Okay, because it's one of the one of the issue that we have to consider. Okay, because isotrope is we want to use we want to separate up between two binary mixture. Find all of the binary mixture that form isotrope with the ethanol. Okay, so it means the other compounds should be miscible with the ethanol. Okay. Okay, and hence that one is in terms of the property constraints. How about the structural constraints? For the structural constraints, you have to, that one is acyclic compound, right? That one is the structure constraints. One is the acyclic compound. Okay. What else can be miscible with the ethanols? Maybe like aldehyde, acids, because they have OH, right? Is a organic compound, right? Ethanol is organic. Okay, you can set. Maybe you can set also the isomer. Okay, done. Okay. So if you look at here, okay, I just set this one binary isotrope with ethanol lah. So I click compound, okay, and generate isomer lah. So meaning that with the isomer also can miscible with the ethanols, okay. And then pre-selections, alcohols, okay, ketone, aldehyde, generate acid, generate phenols, okay, generate esters and also ethers. Okay, this is the organics. Generally, they have CHO. Okay, ethanol also CHO, right? CHO using have a CHO atom. Okay, so that's why we do the constraints for the structures: alcohol, ketone, aldehyde, acid, phenols, ester, and ether. So if you look at here, this is the selected group: CH3, CH2CH, okay, COH, CH3CO, and so on. Okay, so if you want to edit the groups, you can do here. Either you want to delete or you want to add more. Add the one. Okay, and then you can use this one, or you can using edit group. Okay, so for the constraints, we just make it default. Okay, minimum number of group is 2. Okay, and maximum number is 8. Okay, and the rest is just a default. Okay, so because if based on this one, okay, based on these problems, nmax and nu is a 2 and 8. This is minimum number of group. Okay, because if only one group is not stable, right? So at least we have two groups, and the maximum we set 8. This is just a default. So if the problem said you need to maximum number is 6, so you have to change to 6. Okay, and about the minimum number of functional group and maximum number of functional group also you have to set. Okay, so this is when we set the property constraint and also the structural constraint. Okay, so actually this one extended problem control, this is should, if you still remember the rule of Odile and Macchiato. This one, this is a rule of Odile and Macchiato. Okay, so should be follow the Odile and Macchiato rules. Okay, must be stable. One of the criteria is the stable compound. Okay, and then non-temperature dependence. So if you look at here, just right clicks. Okay, so you can set a normal boiling point. Okay, it's stated that 300 to 400 Kelvin, right? So minimum and maximum. Okay, is within the range lah, 300 to 400. If more than 300, so you can untick this maximum. Okay, if in the range, so just 300 to 400, just tick this maximum. Okay, so after that you click this one, the green color, run, so that we can generate the structure, the molecules. Okay, so if you look at here, we have how many compounds design? Okay, 5,614 molecules are generated. Okay, and isomer to 280. Right. So we can actually we can reduce lah. Okay, and we screen here, right? Out of 500, 5,614, 5,165 is not matched. So meaning that how many left? Uh, 5,914 minus 5,516, 5 lah. Okay, it should be 443. And then if we screen, okay, again, okay, 1093 minus 80, okay, 203. Okay, so number of we can reduce to 200 something, 203. Okay, this is the number compound that can be candidate or which is can be miscible with the ethanols. Okay, okay. So if you look at here, this is the compound, 200 something. Okay. 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 So from this one, you can check. Okay. So for example, if you want sorting based on the normal boiling point, the increasing order. Okay. So based on the increasing order or decreasing order, it's possible. If you want to because we just set a normal boiling point, right? So we just either set as decreasing or increasing order, no other parameters. Okay. And the info, this one you can see here. Okay, same info. Oh, sorry. I don't have this data bank. Anyone have here data bank on the right side? On the right side here? Don't have, huh? Maybe problem with my iCast. It should be, there's a data bank here. So you can see the properties and also what else? The structure. Okay. This one. Okay. Mine don't have, huh? I think the problem. Let me check with the propet also, how to see the database.
Doctor, there is a tick for to click before you start searching. Generation.
Generation.
Yeah, there is like a search in database tick. You have to tick it correct so you can find this.
Not really. Generally, that is automatically also here. Even my propet is not working. I think I have a problem with my iCast. It's okay. It's okay lah. I hope that you can generate also.
Yeah,
Okay.
it's called perform database search after
Yeah,
generation.
database search also possible. Okay. Ada database here. Okay. But my propet also not working. It's okay. But I think all of you already know, right? The propet, right? All the information also you can use. There's a how many methods that we can read the database using a CAPEC and propet, and I think it's another one. Okay, I think you already watched them, but this one is not working also, my propet. I think it's
Doctor?
problem with my version. Anyone have problem with the propet?
Yeah, Doctor, can you go back to the propet properties?
This one.
Yeah, where we select those, yeah.
Mm.
You will go down, you will find it down.
Mm.
After we select, yeah, you will find the perform a
Oh,
data.
this one.
Yeah, you click it and do generation again.
Yeah. I think I didn't click this one.
No.
Yeah, data bank. Thank you, my friend.
Yeah, it's
I didn't click. Sorry.
yeah.
I'm not sure my prophet is working or not, but sometimes it's not working.
Yeah, sometimes it has problems.
It's not working my prophet. Okay, I hope that everybody can if not working, you just refresh or not refresh. You have to what is it? Open again lah. Just close and try to open this one, the iCast. Mine is not working. Okay. But this one, I think you can click also the data bank. Okay. I'm not sure calculate property. Okay. So this is the answer lah. Okay. Is it okay, everybody? I hope this is easy case study lah. Okay. Okay. So please please save. Okay. And then the next problem. Can you do this one? Dichloromethanes. Okay. So by the chloromethanes actually is quite hazardous to the environment. Okay, this one. And sometimes when do the isolation or extractions, we have to replace with the other solvent. Okay, like last time I extract the what is it lignin from the biomass, I have to replace this dichloromethane because the maximum concentration that can be released to the water actually is below than 10 ppm. Very small. Even if you after you use the pipette, we cannot wash directly in the sink by using tap water. Okay, it's more than 10 ppm. That's why we have to replace this dichloromethanes. Okay, so which is a very well-known solvent used in organic synthesis. This one, as I told you, organic synthesis. Right? Okay, note that DCM is hazardous chemical whose release into the atmosphere need to be strictly regulated. Okay, dichloromethane, dichloroethanes, that one is really hazardous. Okay, we have to replace like using a chloroform or it's very we have to replace with low hazardous chemicals. Not only carcinogenic. Okay, when inhaled can affect the central nervous system. Okay, so can you do this one? Dichloromethanes. The property constraints, okay, since this is the organic synthesis, okay, so it should be dissolved with the when you do the what is it, the synthesis, it should be solubilized lah with the compound that you want to synthesize, okay. So should be have a solubility related properties in terms of boiling point, okay, melting point, okay, solubility parameter, okay, log KOW, okay, or water lah, okay, and also rho L. So you can substitute this one. This is the constraint. Okay, can you do? Okay, because if you the important thing, the property constraint is solubility related properties, meaning that the solvent should can solubilize with the compound that you want to extract or you want to synthesize. Okay. Okay, this one in terms of the property constraints. In terms of the structural constraints, okay, I think it's similar like a dichloromethane, which is acyclic. Okay, must have a carbon, hydrogen, and oxygen. So you can set the what is it? Group what group? Alcohol, ketones, okay, aldehyde acid, ester ethers. Okay, that one you can choose. Okay. Okay, can you do this one? I'll give you about 5 minutes. Dichloromethane. I give you 5 minutes. Hope that you can do. Okay. So can you put this constraint?
Doctor, what's the third one?
The third one,
T, yeah, the
delta T.
megabyte something. Yeah,
Delta,
delta.
delta T is a solubility parameter. Okay.
Okay, solubility parameter. And the last one, density.
Wait, rho L, I think you can find it. Okay, sorry. Rho L, octanol solubility. Let me check rho L. Liquid density. Boiling point. Total solubility parameter. Total solubility parameter is a delta T. And then octanol solubility. Octanol solubility. Octanol solubility. Okay, log KOW is octanol solubility, okay? Octanol solubility. Delta T is solubility total solubility parameter lah. And then rho L. Rho L what?
Doctor, the log K means there is something here called log water solubility, isn't it?
Octanol solubility. Wait.
There is something called log water solubility.
Log water solubility, right? That one
Yeah,
have. Like water solubility, sorry.
yeah, it's
Water solubility. What Rho L. Density dia density or not? Totality refractive index. Oh, what? It's not available here. Can you check in the Google? Solubility parameters.
Yeah, I'm checking now.
Group F. Also have no answer actually. Should be density, right? Full of density actually, but not available, man. It's okay. Just omit that one first. Later I will confirm. Even I don't find that symbol, it should be density of liquid. But here not available. Because raw air, right? Density of liquid. Water solubility. KOW dot water solubility. Solubility. No, no. Sorry. For the log KOW is octanol to water solubility. Log P. Okay, should be log P. This one. Okay. Log KW. Okay, you can find right octanol to water solubility. Log K. Okay.
Okay, doctor. Okay.
It's not oil, it's octanol. Only for the density liquid, this one. That one is just omit. It's okay. No need to put. Okay. So More than one. So the answer is going to be different, a little bit different. Okay, so this one, where I did. So I just acidic click compound generate isomer, and then I click alcohol ketone aldehyde generate ester generate ether. Okay, and the rest is defaults. Okay, 2, 8, 6, and 6. And then for the non-temperature, I just set normal boiling point, uh, uh, normal melting point, total solubility, okay, external to water solubility, and I just omit that row else, okay. Okay, we have to omit that one. Later I will confirm what row L this one. Okay, and then you just generate. Okay. So isomer we don't get number of isomer is 394. Okay. So let's recheck this one. External to water solubility. Okay. Okay. So how many? 200, 2000 something, right? Okay. So you can get 2000 something lah. Okay, the number of compound that can be generated, and then you can screen. Okay. Okay. Later I will find out the row L. Okay. So this one is because I think it's because of the one properties or constraint that we did not include, that one is the number of isomers selected is equal to 0. Okay. Okay. So actually we can reduce. We can screen out of the 394, 43 is not within the what is it? We not within the what is it? We can omit 43, and 351 we can omit 120 lah. Okay, and so on. This is if we screen out based on the octanol and water partitions. Okay, if you screen out based on the boiling point, also you can screen lah. Okay, this one based on the what is it? This one is based on the primary calculations. Now octanol water partition. Okay, melting points and so on. Okay. What is it? They have a melting points 250. Yes. Oh, maximum. Yes, maximum should be 250. Okay. Maximum 250. Because
Should be minimum, doctor.
huh?
According to the
If
constraint.
minimum, if minimum,
Yeah.
if minimum,
According to the constraint, it should be minimum more than normal.
it should be below than 250, right? Melting point.
Bigger than.
Not, we did not set the minimum. We set the maximum. Should below than 250 lah. Maximum 250 lah. Okay. 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 So this is and the rest actually for other case study, I think you can try in the textbooks. Okay, they have many exercise, I think. Let me see. I'm not sure. If you want to try, 4.8, right? 4.8, I think you can try by using this one. The problem 4.8, yes. And also 4.7, you can try. Okay. So there's a constraint already provided, the constraint, and you can try. Okay. So yeah, I think you already try with from the video presented by Dr. Azizul and Dr. Alafiza. Okay. I think so you familiar with this CMD and also Propet ICAS software. Okay. So if you can't, if you cannot run this one, I think you have to restart again your ICAS. Okay, because this is not like a commercial software. Okay, even this one IT software, we got it from Dr. Alafiza's supervisors and Dr. Aziz's supervisors. Okay, so that's why it's only for educations. Okay, not for other purpose. Okay. Okay, so that's all for chapter 5, chapter 4. Um, we finished already this chapter. Okay, so previously, we stopped at if you remember, we stopped at the first order. Okay, we just already discussed with the coordinator. Our topic is until first order lah. Second order, third order, we not cover. So you can omit that one from your PowerPoint slide that I've provided to you, right? If you look at that in the PowerPoint slide. But last semester I explained second order and third order. So from the slide, it's, wait, search. Okay, 105, part 5, that one, part 5, right? If you look at my PowerPoint slide, okay, slide 105, okay, molecular and mixture design part 5 until the end, okay, until slide 152. Okay, that one we not cover. Yeah, only first order we cover. So meaning that if you still remember the equations, okay, this one, okay, so starting from here, 105. So you should familiar with this equation now. First order is very easy. Okay, this equation for f theta and also the right side NC MD plus EO. Okay. So since that's one, I think I'm thinking to do this question, this type of question. Okay. So this one is just omit from your slide until here, till this one. Okay. So you can have. Okay. Any questions for chapter 4? Okay, for the project, actually, we will cover all chapters starting from chapter 1 until chapter 19. We have only five chapters actually. 5 chapters. First chapter is introduction to the chemical product design. Okay, design literatures. Chapter 3. Chapter 4, molecular and mixture design. Chapter 5, device functional and formulated products. And chapter 19 is business decision making. So only 5 chapters. Okay. So now we are cover chapter 4 and next chapter 5. Okay, any questions? I hope that today is the last submission for assignment 3, right? So you have to submit. If you want to confirm your Odile and Macchiato also, you can use this software. Okay, set the constraints and you can see how many molecules that you can generate. Okay, so if no questions, we have a break for about 10 minutes before we start again, 12 o'clock. Okay. Okay, we start with the new chapter 5.